on anonymous inner class. Okay, the topic we're going to talk about in this segment of the presentation is Java exception handling. So we'll talk about what exception is, and we will see what happens when an exception occurs in your Java application. We'll talk about the benefits of having exception handling framework as part of the programming language. Java provides exception handling framework built in, so that's actually a good thing. So we'll talk about why that is actually useful. As part of the exception handling framework, Java provides try and catch and finally. So we're going to actually talk about this too. And we'll talk about throwing exceptions. You can create your own exception yourself by throwing an exception. And we'll talk about the rules of exception handling, especially from the perspective of checked exception. I will talk about exception class hierarchy. So exception is a genuine class, so it does in fact have exception class hierarchy. We'll talk about the concept of checked exception versus unchecked exception, and we'll see how you can create your own exception class and throw that class, the exception class. And lastly, we'll talk about assertions. So what is an exception? Yeah, exception represent an exceptional event. Okay, kind of obvious, and typically it's an error that occurs during runtime. Okay, so you know when there is a problem in the code, that's a compile time error, right? Compiler error, and when we say exception, you're talking about runtime exception. So when this exception occurs, it causes the normal program flow to be disrupted. Okay, typically it gets stopped, or you can handle it and then proceed if you want to. Okay, but if you don't handle it, then it will stop the application. Exception examples. It could be programming errors, it could be normal program errors, or it could be system errors. Programming errors is that, for example, divide some number by 0. Obviously, that's your programming error, right? Okay. Hold a second. Okay, normal program errors is probably not your programming error. Oh, you still hear the ringtone? You don't hear the ringtone, right? Okay, so all right, so normal program errors is not your programming error, but it's actually part of the running of the application. For example, you ask for user to enter some value, and if the value is not the valid one, value that was entered is not valid one, then it might actually cause an exception. Again, you have to handle it. Opening a non-existing file, that could be a possibility. Or it could be system error. System error is like a heap memory exhausted and things like that. So that rarely occurs. Okay, so example code of exception, that is example case where exception will occur. So if you try to divide a number by 0, that will cause arithmetic exception. Okay, yeah, so this is an example where exception could occur. Okay, so when you actually run that application, what you are going to see is this: exception in thread main and java.lang arithmetic exception, and you're trying to divide by 0. This is the name of the class, and this is the name of the method, and this is the line number. So this message is actually coming from Java runtime. Okay. And in fact, this is handled by what is called the default exception handler. So Java comes with default exception handler, and it prints out this exception description. So this is the exception description, and it prints the stack trace. In this case, we have a single line. We have a single method, so it doesn't actually display several method stack trace. But if exception occurs in the call chain, then it will display all the call stack, meaning stack trace. Okay, and then it will actually stop the application. Okay, so that's what happens when default exception handler is being used. So that is exercise 1.1. So if you actually take a look at the exercise 1.1, it's just running that application and experience that problem. So that is divide by 0. So this is divide by 0. So if you take a look at the code, that is the code that I just talked to you about. So here is main Java, okay, and we are going to run the application. Oh, yeah, looks like I did the debug it. Okay, toggle breakpoint, and let's run this application. Okay, so this is what happens, and we have actually a single method in the stack trace. Okay, I mean, if you actually try to call, if you can certainly create another method, then you can see another stack trace, static and void junk method, and we are going to call this guy, and let's just call like a junk like this. Okay, so now if we run this guy, and we can see the stack trace is actually in the main 0. Oops, sorry, and then is actually calling junk method. Okay, so this is all handled by the default exception handler that comes with the Java. Okay, all right, so since that's pretty straightforward, let me just move forward. So what happens when an exception occurs? So when exception occurs within a method, it gets detected either by Java runtime or business logic code in your application. You can certainly capture an exception and you can handle it. And then exception object gets created either by Java runtime or in your code, and it hands it off to the Java runtime system. Okay. So by the way, creating an exception object and handing it to the Java runtime system is called the throwing an exception. Okay, so later on we are going to in fact do exactly that. Okay, in this case, that is actually being handled by the Java runtime. Okay, but meaning Java runtime actually create the exception and throw create an exception object and throw that exception object to the Java runtime itself. Okay, an exception object contains information about that error, including exception type and state of the program when the error occurs. So you can actually capture this exception object. You can find out more information. Okay, so this is actually what happens. Suppose we have a main method. Main method will call a method, and let's say this one has the exception handler, and then this guy called another method, and this guy doesn't have an exception handler, and then it calls another method. So suppose there is an error on this method. Okay, what happens is that it will try to find a method that can handle this exception through this chain. So it will actually check whether this can handle it. It doesn't have exception handler. It will actually check whether this method has an exception handler, and because it doesn't have it, it actually goes the next in the chain. Now this guy has the exception handler, so this guy will actually handle that exception. If it doesn't, even this guy doesn't have exception handler, then it will be handled by the default exception handler. That is in fact the case of this. Okay. So let's talk about an example of a method that can handle an exception. What do you mean by exception handler? What do you mean by a method can handle it, or a method with exception handler? Okay, so the method that has exception handler, or a method that can handle exception, is the one that actually catch the exception and do something about it. Okay, with a try and catch. So when random access file, when you're trying to access the file, if there is an exception, like a file not found exception, in this case we catch the statement, and it will catch this exception, meaning this is the logic that handles the exception. Okay, so in our previous case, when we say method with an exception handler, we are talking about a method that actually catch that exception and then handle it. So this is the handler logic here. Okay, so it handles it and it just moves on. Okay. Okay, so method without exception handler. So if method does not have an exception handler, it should at least throw that exceptions. Okay, so it throws an exception. That means I cannot handle this exception, so somebody else in the chain has to deal with it. Okay, so this is an example of this guy, method without exception handler. So basically by throwing it, it will just ask next one in the chain to handle it. Okay, so in our case, this is the one next in the chain, and this is the one that doesn't want to handle it. In that case, it throws a file not found. It throws that exception at the method level. Okay. Okay, so the continuation of what happens when the exception occurs. So this is something I kind of talked about already. So when a suitable handler is found, then Java runtime passes the exception to the handler. So basically, this is the logic. Java runtime, this method, concatenate method, can handle file not found exception. So exception occurs here, right? And then, this guy has a handler. So it will actually pass this file not found. It will create the Java runtime will create the file not found exception object and will pass that guy as an argument to the handler. So here you can actually handle it. In this case, we just display the message. Okay. So exception handler is considered suitable if the type of exception object thrown matches the type that can be handled by the exception handler in a method. What it means is that this guy, this type, file not found exception, should be the type of exception that has occurred. Okay, so if this one does not match, then this guy cannot handle it. Then it has to actually, handled by someone else. Okay, so this is the type that has to match. And then exception handler chosen is to handle catch the exception. That is the catch statement we just saw. Now, if no method has the exception handler, meaning if the runtime exhaustively searches all the method on the call stack without finding appropriate exception handler, then runtime uses the default exception handler and terminates the program. So that is the case. So because there is the so in this case, junk method is called, exception occurred, and there is no exception handler in this code. So that's the reason it has to actually go up the chain, and since there is no handler here, the default exception handler comes in. So if you want to handle it, you can just use the try and catch. So here, basically here, like this, you can just move this guy right here, and then we can actually, so exception is in fact the root type, root class of all exceptions. So we should be able to actually catch whatever exception that happens here, right? So in this case, we're going to just handle it. So exception occurred, and we might want to actually print out the exception object information. Okay, so this exception object should actually print out all the stack trace and things like that. So let's actually try to run this guy. Okay, so exception occurred. So basically that is coming from this message. We just handle it. Okay, and because we handle, we should be able to actually continue the process. So if we have another statement like this, and next message or something like that, and then when we run it, so this is the from the handler, and then we are just seeing this message as well. Okay, because once it is handled, then it's a normal flow. It just continue to work. Right. All right, so that is basically what's happening. So just looking at the what's happening behind the scene from the picture. So suppose there is an exception is thrown, looking for appropriate handler. because this does not have exception handler itself, it forwards it, and then it, this guy has an exception handler, it handles it, and then it will just proceed. And that's basically what we actually play around here, right? Okay, any questions so far? So let's talk about the benefits of, let me see, looks like I'm missing some questions. Okay, no questions yet. Benefits of exception handling framework. So Java comes with this exception handling framework, and it provides several benefits. First benefit is the most important one. It's a separation of error handling code from regular business logic code. Okay, so it actually results in cleaner code because the error handling code does not get mixed up with the business logic code. Okay. And benefit number 2, whoever best suited to handle the error will handle the error. Okay, so because the errors will be propagated up in the call stack until suitable handler is found. Okay, and third benefit is that grouping and differentiating errors based on their type. So exception classes are genuine Java classes. Okay, so you could, in fact, the exception class has this class hierarchy. So based on this class type, you could actually do different things. Okay, so grouping and providing different the handler based on type is possible. So these are the benefits of having exception handling framework. So let's talk about each of these aspects in a bit more detail. Separation of error handling code from regular code. Suppose we have some kind of a logic like reading a file, and reading a file involves a lot of actions like opening a file, determines its size, allocate memory, and read that file into memory and close the file. Now, each of these actions could actually have a potential. Each of these tasks has a potential for causing an exception. Okay, so if there is no exception handling framework, you basically have to deal with these exceptions as part of your business logic. So you are mixing up your business logic with error handling code, and it can get very, very hairy. Okay, so that's actually one benefit of the having exception handling framework, separation of exception handling from business logic. So this is in fact Java. In fact, Java, you basically all the business logics are captured inside this try block, and then all the error handling logic will be captured in catch block. Okay, so we can actually suppose there are many different types of errors. We can catch each of those type of errors and do something about it, like a file open failed, size determination failed, memory allocation failed, read failed, file close failed. So we are handling all these possible error handling cases in its own error handling block. So there is no mix up between business logic and error handling logic, and this is a very, very good thing. Okay, propagating errors up in a call chain. So suppose we have method 1 calling method 2, method 2 is calling method 3, and method 3 is calling read file, right? So if that happens, in traditional way of propagating errors, meaning if there is no exception handling framework, basically we have to actually check all these things ourselves and propagate, and it gets very, very hairy. Okay, in Java exception handling framework, that propagation is built in. Okay, so again, that's advantage. The propagating errors in Java. So that's basically, so this is how Java does. So basically, if there is an error, so the throws an exception, basically these two guys do not want to deal with it. So basically, it just pass it up the chain. So until the Java runtime finds a method that actually has a handler. So this is the one that actually handles the exception. Okay, so this is how Java handles propagation of errors. And grouping and differentiating errors. So because all exceptions thrown within a program are genuine objects, meaning they are object from a Java exception classes, grouping and categorizing of exception is a natural outcome of class hierarchy. For example, so there could be IO exception, and IO exception is most general and represent any type of error that can occur on performing IO. Okay. Now, IO exception is in fact the parent class of file not found exception. Okay. So sometimes you want to just catch everything related to IO, and sometimes you want to just catch only this particular exception, file not found exception. Okay. So you can, you have a freedom or flexibility in terms of using this exception type to group group related exception classes and handle it accordingly. So in the case of the if you want to just handle file not found exception, then you say you just catch with that exception type. Okay. So any file not found exception will be caught. So it's not just a file not found exception object, but any subclass of file not found exception will be caught by this handler. Okay. So if the file not found exception has no descendant, so this one doesn't have any descendants, so that is pretty much it. But suppose there is a child class of file not found exception, you could actually create your own, in fact, which is a child class of file not found exception. Then this handler will handle that child class exception case as well. So you can actually catch errors with a super type. So if you want to catch all IO exceptions, then you are going to use IO exceptions. So this will catch not only file not found exception, but it will also find the end of file exception and things like that. Okay. Okay, moving forward. Catching exceptions with try and catch. You already have seen try and catch already. So the syntax is like this: try, and this is the business logic code to be monitored for execution. So if there is an exception occurs when the logic within this try block exception occurs, and then this catch block will catch that exception. So you could have a multiple catch statement. Okay. Multiple catch block. So this is an example where we catch the arithmetic exception and then deal with it. Okay. So in fact, here instead of catching exception, I can just use the arithmetic exception, and that still should work fine, right? Okay. So yeah, so that that should be actually catch. But if you try to use like a file not found exception, so I'm going to use like a file not found exception. Okay. And file not found. What is the problem here? So to do unreachable catch block for file not found. Oh, okay. Yeah, it actually knows that there is no possibility of file not found exception because we are not actually doing any operations. The compiler is intelligent enough to know that there is no possibility of you are going to have a file not found exception. That's the reason it doesn't like it. So if I actually perform some kind of file operation, then it will actually take it. Okay, so this is probably not a good example. Okay, all right. So let's see. Okay, so and you can actually suppose if you have these two statements, you are parsing some kind of argument. Okay, so there could be a possibility of array index out of bounds exception. Okay, because if user has not entered anything as an argument, then this there is nothing in arg0, right? So that will cause array index out of bound exception. And this second line will actually cause, it could actually cause arithmetic exception. So you can actually catch different types of errors. Okay. Okay, so that is try and catch. Now let's talk about the finally. So you can also have a finally at the end. Basically, finally block contains code that gets executed regardless of whether there was a failure or not. Okay, so if you want to actually have some kind of code that needs to be executed regardless, then you can have it inside finally. Okay. Okay, so finally, so block of code is always executed despite on different scenarios. Okay, so these are all different scenarios, and regardless of these scenarios, normal completion or the exceptions thrown, whatever, the block in finally will be executed. Okay, so this is an example. So we have many different cases, and we catch an exception, and then this one. This finally block will be executed. Okay. All right, so now let's move on to thrown an exception. So far we did not throw an exception ourselves. Basically, we actually perform some operation, and because this operation caused an exception, is actually the underlying Java runtime system is going to actually throw an exception. But in many cases, you want throw an exception yourself, meaning you want to you want to create an exception object and throw it yourself. Okay, so that's what this is all about, throwing an exception. So basically, Java allows you to throw an exception. Basically, when we say throw an exception, basically generate an exception using throw keyword. So you can actually throw and you create an exception object. Okay, because exception object is a genuine object, you have to create an object by using new keyword. Okay, so if I want to, so instead of actually performing this operation, I can actually throw. I can just generate the new exception myself. Arithmetic exception, like this. Okay, and this will in fact have the same result. Okay, is in our previous example, when you are dividing 3 by 0, that logic get executed, and then Java runtime will actually create this arithmetic exception itself, and then it will throw. But in our case, we are just throwing it ourselves. You are basically generating that exception explicitly. Okay, and of course, typically you can actually perform some kind of business logic here. Perform business logic, and based on this business logic, you might in fact throw an exception. Okay, all right. So the way you throw an exception is basically create an exception object and then throw it. Okay. All right. So yeah. So in this case, when we are trying to see whether input is equals invalid input, then we actually create the exception object. Okay, so in this case, we are creating runtime exception object. Okay, so we'll talk about the exception class hierarchy later on, and runtime exception is this is a subclass of exception class. Okay, rules in exception handling. A method is required to either catch or handle exceptions by itself or pass them along the chain, except error, a runtime exception, or their subclasses. So these are called the non-checked exception. So as far as the non-checked exception, as far as they are non-checked exception, or we are talking about error or runtime exception, you don't have to actually follow these rules. But if an exception is checked exception type, then a method either catch it or either catch and handle it, or it has to pass along the chain. Okay, so the we have seen the handling is basically you have a try and catch block. If you do not have a catch block, meaning you don't have an exception handler, then you have to pass it along the chain. The way you do is basically you throw and then you provide that exception type. Okay, yeah, this is a little bit I'm going to actually show an example, and we're going to actually do some the hands-on lab as well. Okay, so this is the case that we are throwing class not found exception. Okay, because class not found exception is checked exception, so you have to follow this rule. Okay, so either you have to catch it and handle it like this, or you have to pass it along. Okay, so in this case, throws demo, throws demo that's the one that actually contains a main method. Main method will actually call the method of this throwing class, right? So it actually throw the class not found exception explicitly, so exception has occurred. So either this method should deal with it with the try and catch, or it has to throw it. So it decides to throw it, and then because it actually throws it, meaning it actually throws to the one in the chain, call stack chain. The next one in the chain is this main method, right? So this main method can actually catch it and handle it like this, or if it doesn't handle it, then if it doesn't handle it like this, then it's a compiler error. Okay. You know what? I'm gonna actually show this one. So let's actually demonstrate it, so there are in fact the checked exception and the unchecked exception. So this is a checked exception case. So you're gonna actually do this one in hands-on lab later on. So one of the examples of checked exception is the file not found exception. Okay, so we basically it looks like I lost the code. It's actually, this is the code. Looks like I didn't actually make it. Okay, so file not found exception is a checked exception, so that has to be dealt with. Okay, so there are several ways that you can deal with. One is you can actually provide try and catch. So in this case, when this file not found exception is thrown, we are basically providing catch block, okay, and handle it. Okay, so this is one way of handling. Otherwise, if you do not want to handle it, then you have to throw it so that someone in the call chain handle it. Now, if you do not handle it, so let's say you just throw file not found exception and do not handle it, that's a compiler error. Okay. Now, this happens only when when checked exception is this rule only applies to checked exception. Okay. So as I said before, if you take a look at the file not found exception, if you take a look at the Java documentation of file not found exception, this is in fact the IO exception. IO exception is a checked exception. I'm going to actually talk about the checked exception and non-checked exception later on in a bit more detail. So now if you actually go to the unchecked exception, so this is the sample code, unchecked exception here. So arithmetic exception is an example of unchecked exception. Okay, so because it's a subclass of runtime exception, and runtime exception is the unchecked exception. In this case, you don't have to follow that rule. You don't have to actually catch it, and you don't have to throw it, because this is the runtime exception. Okay, all right. So I am going to actually ask you guys to do exercise 1.2 and 1.5. So that is basically what is that exercise? So basically, so this is a multiple catch, and this is the array out of exception case. Okay, and call exception methods. So basically, just when we get the exception object, we can just display the messages and So these are all methods from exception class. Okay. All right. So that is pretty much it. Yeah. So that's pretty straightforward. Okay. So let me just continue. Any questions so far? Okay, so how to create a custom exception. Basically, exception class is genuine Java class. So you can extend the exception class. Okay, so you have, yeah, so this is basically the next topic, exception class hierarchy. So there are the throwable is the root class of all exception classes. So immediate subclass is error and exception. And so exception class is basically the conditions usual programs can reasonably deal with. Okay, and errors are like a system errors. Okay, so exception class is typically like division by zero error, that is arithmetic exception, and array out of bounds exception, like that. Okay. And error class is actually, again, typically system error. So this one, there is nothing much you can do about it. So that's the reason, the error class, you don't have to actually follow that rule. You don't have to actually catch it and deal with it, and you don't have to throw it. Okay. So this is basically the exception class hierarchy. So on the top, we have a throwable, then we have an error, then we have an exception. So exception class have a bunch of exception child classes, and then we have a runtime exception. So runtime exception have a child class of arithmetic exception, array store exception, class cast exception, and things like that. So these runtime exception and its subclasses exception, and also this error, you don't have to catch it, you don't have to throw it. There is no compile error will occur. However, these exceptions, okay, these exceptions, class not found exception, IO exception, all these things, you need to follow that rule, otherwise a compile error. Okay, so for that exercise we just did, so let's say I go to what is the checked exception. So in this case, if I use the arithmetic or runtime exception, if I use the runtime exception, let's see, oh, it's misspelled, runtime exception, this is the one. Okay, yeah, so because runtime exception is unchecked exception, okay, so we call this runtime exception and error as unchecked exception because you don't have to check it. Rest of the exception, those are called the checked exception because you have to check it. So in this case, because this is non-checked exception, you don't have to actually follow it. You don't have to catch it and handle it, and you don't have to throw it. Okay, and there is no compiler error. Now, if you try to throw, let's say IO exception. Okay, IO exception. That is a checked exception, so that's a compile error because we didn't deal with it. Is that clear? Okay, now the question to Dimitri, how to implement the custom exception. Basically, you are going to extend this exception. If you want to make your exception to be unchecked exception, you are going to extend runtime exception. If you want to make your exception to be checked exception, or if it is related to IO exception, then you are going to extend IO exception class. You're going to create the child class from IO exception. Does that make sense, Dimitri? Yeah, you're going to actually do that exercise later on in the hands-on lab. Okay, so exception class hierarchy. So basically you want to catch the more specific exception object first before catching general exception. In fact, if you try to catch this one before this guy, that's a compile error. Okay, so multiple catch, when you do have a multiple catches, and if those guys are, if these exception classes are related by inheritance, then you have to have you have to actually have subclass first and then parent class. Otherwise, it's a compile error. Okay, so this is creating your own exception case. So basically, depending on whether you want to create a checked exception or unchecked exception, if you want to create unchecked exception, typically you are going to extend runtime exception like this. Okay. Okay, so in this case, we actually created hate string exception and extends runtime exception, and here we actually throw it, and you don't have to catch it because this is non-checked exception, but we decide to catch it anyway. Okay. Yeah, so that is exercise 2. So if you take a look at the exercise 2, yeah, I'm gonna actually ask you guys to do this exercise on your own time because we have only 5 or 6 minutes. So I want to actually finish this up, at least the presentation. So here we created our exception class. It extends the exception class. So this is our custom exception class. Okay, and then we are basically we throw that exception, and yeah, so we have actually F method, G method, and both of these is actually throwing my exception. Okay, yeah, so nothing fancy, and in this case we are creating your own exception example 2. So here, yeah, so we're actually performing some kind of conversion operations, and yeah, okay, so this is my custom exception, invalid hex exception, and again we are extending runtime exception, and basically we are using it. So in this case, because it's runtime exception, we don't have to actually throw it. This one doesn't need to be done. Okay, because it doesn't have to follow that rule. Okay, so here we throw that exception. Okay, all right, so not a big deal here. Okay. Yeah, so here we actually created the multiple exceptions in a hierarchical structure. So we have my parent exception and then my child exception, which is extending my parent exception, and then we are basically catching either of those from the child exception first. Okay, otherwise there's a compile error. Okay. Yeah, so this is, when you have reverse, it's gonna actually cause a compile error. Okay, all right. That's what you're going to experience. And finally, you can have a finally here. Yeah, so we talk about ignore runtime exception. Okay. Yeah, so that is, yeah, and then exercise 3 is what I actually showed you to. Okay. So this is a case where unchecked exception does not have to be dealt with, or it doesn't have to be caught. I mean, it doesn't have to be caught and dealt with, and it doesn't have to be thrown in the call stack. And this is the checked exception, where we are throwing the file not found exception. That's a checked exception, so we have to deal with it. So one way to deal with it is, again, try and catch and handle it, or you throw it. Okay, and if you don't do either of those, it's a compile error, as I talked about. Okay. Okay, so yeah, that's basically checked exception, unchecked exception. So checked exception, Java compiler checks if the program either catches exception or pass them further up the chain. If not, compiler error. Unchecked exception is not subject to this rule, compile time checking. Okay, so built-in unchecked exceptions are error, runtime exception, and their subclasses. Okay. In general, the trend is to make your custom exception to be subclass of runtime exception, so you don't have to actually be constrained by these rules, because this try and catch and all that stuff is actually kind of confusing, and it actually clutter your code. So general trend is make everything as a runtime exception. In fact, in Spring Framework, they make every exception to be runtime exception, so that you don't have to deal with this try and catch handling and throwing an exception rule. Does that make sense? Yeah, question from Robert. Is throw the same thing as saying return? Well, the throw is only used for the causing an exception. So it's not really return from a method. It's causing that exception right on that line. Okay. Does that answer your question, Robert? Okay, so moving forward, so that is the exercise 3, which I actually showed you already. Assertion. So assertion could be actually useful. So assertion, you can actually insert assertion statement. You want to actually have this assertion statement here and there to make sure your programming is actually running as expected. For example, let me see. But in order to have your assertion to be enabled, you have to run your application using this flag, this option, enable assertions. Okay. Excuse me. Now the assertion statement like this: assert and expression one, or you can use the expression one and yeah. So this is a condition and is some information helpful in diagnosing why the statement failed. Okay, so typically you're gonna actually use this notation. So let's say an example. So in my logic, I want to make sure age is always greater than 0, right? The age cannot be negative value. So it's actually a good thing to have this kind of assertion statement. Okay, all right. But you do not want to have this assert statement to be in fact executed in your production environment. So typically you want to use this assert statement in your development time. Okay, so that's the reason you have to specify this option to run the application. If you enable assertions with this flag, and then this assert statement will be checked. Otherwise, this is not gonna be the executed. So in production environment, you don't want to actually have a performance the problem because you have this assertion statement, right? Okay, so as a default, this doesn't get executed. Okay, and if you want to get this assert to be executed during development time, you have to start with this enable assertion flag. Okay, all right, so that is exercise 4. So if you see that exercise 4, yeah, so basically we just check whether yeah, so this whole thing is probably not that much important. We basically check whether size is greater than 0. Okay, so when you do this, and you have to actually run this guy with the properties, and then you have to actually have this -ea. In the case of Eclipse, you have to actually create the configuration file, and within the configuration file you can actually pass this option. Okay, VM option. Okay, and if you say -5, then assertion failure occurred. Okay, so okay, sorry, I felt like I rushed up a little bit because I wanted to finish this guy. Okay, so let me just